Welcome everyone, and thank you for joining today. The focus of this presentation is on using the GEOWEB 3D confinement system and installation best practices. This presentation assumes you are already familiar with GEOWEB geocells and their integral components, so it's going to bypass some of the basic background information and focus on next level and intermediate techniques. Please see our on-demand resources available at prestogeo.com for a deeper understanding in any one of the applications covered today. And as always, for more information, please reach out to our team, info@prestogeo.com. You can request additional training or even lunch and learns with any of our team, and we'd be happy to go into more info for you. I'm Jose Paulo George, or JP, the business manager with Presto Geosystems. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States, through an extensive national and international distribution network. We offer technical and site support, as well as free project evaluation from our in-house design engineering team. Today's presentation will help you leverage our over 40 years of geocell experience and get installation best practices and technique tips. So here are the things I hope you get out of today's presentation. Understand the benefits of using a soil stabilization system for the major applications of load support, slope protection, channel armoring, and earth retention, with some fundamental installation steps for each. Gain install technique tips to make installations more effective and efficient, and how to train your team to set them up for success and ensure the best project outcome. During the presentation, if you have any questions, please do type them into the chat window and we'll answer them after the presentation. Everyone will get a follow-up email with a link to this recording. If you are joining us live today, I'll answer your questions in the order received at the end. Presto worked with the U.S. Army Corps of Engineers to develop geocell technology in the late 1970s, and we've been innovating ever since. Our products have been used in nearly 200 countries and in every state in the U.S. But we go beyond simply providing a product to helping you provide a solution, all with an eye toward providing that complete solution for your project and your end client. We're going to start out with a quick recap of the GEOWEB 3D soil stabilization components, and then get into technique tips for installing each of the major application types. Again, for additional details or a deeper dive into any one of these applications, see our website, prestogeo.com. The three primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. GEOWEB is manufactured using a proprietary blend of high-quality virgin high-density polyethylene, and our formulations have stood the test of time for more than 40 years. We stand behind our numbers so you can deliver certainty in the solution and build with quality materials you can trust. GEOWEB and our accessories are 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for Build America, Buy America, and the Infrastructure Investment and Jobs Act. Presto Geosystems, the leader in geocell technology, is proud to announce the publication of the industry's first Environmental Product Declaration, or EPD, for geocells. This milestone reinforces Presto Geosystems' ongoing commitment to reliable infrastructure and environmental quality. The system components are all the supporting pieces that help the GEOWEB protect the surface and base layers, and also ensure relatively uniform performance of the interconnected system, thereby protecting against the damaging effects of non-uniform deformation and differential settlement in response to applied loads. Presto's GEOWEB system components increase strength and speed of installation, each of them offering some additional best practice options that we'll mention in context and with installation examples. So let's dive in. Let's begin with installation techniques for the GEOWEB load support system. The first pro tip is to use a quality engineered solution best suited to your project needs. Uniform and consistent, proven performance and durability, especially in demanding site environments, will be well worth it in the long term, and our in-house design team can help you choose the right geocell size based on your site conditions. Soft subgrades like the harbor wetlands seen here are where GEOWEB geocells shine. So here's a quick overview of the installation process. You start by getting the subgrade ready, then geotextiles or other planar geosynthetics as required by design. Next, lay out the GEOWEB sections. The GEOWEB sections are then interconnected, and that connection is usually the ATRA key. The ATRA key connector is shipped in convenient to hold 3 packs per case, as you see in the photo on the left. This mini pack can be carried to where connections are made, and that's a good technique tip. A pro tip is to use contractor pouches or aprons for a hand-free way to hold and carry the keys and make the fast connections even speedier, as you see in the 2 photos on the right. The specific engineering values of the ATRA key will ensure the system holds up to loading over time without the corrosion seen in staples, the failure of underperforming cable tie systems, or cumbersome multi-piece connectors requiring you to do hand acrobatics on the job site. You'll want to hold the GEOWEB sections open for infilling, either with temporary stakes or by filling a few cells around the perimeter. We'll see some examples of that in just a few more slides. The infill is placed, spread, and compacted with an appropriate wear surface. And according to design, that could be an unpaved surface, a flexible pavement, or a rigid pavement atop the GEOWEB. Let's look at some examples from an unpaved load support system first. An aggregate surface has advantages in saving pavement costs, and with the GEOWEB system filled with open graded base course, you can design a system that allows stormwater infiltration and provides stormwater storage. This was a project for a sawmill in Canada. Spring snow melt and fall rains cause flooding and soft, challenging ground conditions in the infeed area. And this photo is great to see how the GEOWEB was placed. Held open with stakes at the perimeter, and then the infill was spread. Presto worked with the owners to develop a design to manage stormwater and snowmelt while providing stabilization and support of the heavy loads over the soft subgrades. A 6-inch or 15-centimeter GEOWEB load support system with high-strength woven geotextiles was installed, with the infill designed to promote stormwater infiltration. Here we see the GEOWEB sections expanded, and the workers are just beginning to connect panels side to side with the ATRA key. This design included a permeable base layer with less than 10% fines for stormwater purposes. The GEOWEB system provides a strong reinforcement layer for the constant heavy loads that the mill infeed sees daily. Here we see the infill being placed, and good technique is to limit the drop height to 1 meter or less, about 3 feet, to ensure the empty geocells don't fold over and are evenly filled. GEOWEB created a smooth platform that eliminated the rutting and constant maintenance, and both project owners and installers were pleased by the ease and speed of installation thanks to the ATRA key connectors. Here we see a good technique tip with crews working in parallel. On the far left, the placing of the infill by the excavator, while workers expand and connect new sections of GeoWeb. Far right, we see the roller compaction of the infill. Having a crew with well-defined roles allows this kind of work in parallel and install best practice, and makes for an efficient installation. To ensure everyone knows what to do, take advantage of contractor training available, including a construction resource package, training guides, videos, webinars, and even in-person or virtual seminars. See prestogeo.com or any of our trusted distributors for more details. This is a good GeoWeb load support project to demonstrate using the GeoWeb as its own site access during construction. This was a project for Duke Energy in Florida to install new transmission towers through the wetlands. Hurricane winds demolished over 100 towers, all of which had to be restored over this extremely soft subgrade, and the saturated sand could not support any type of vehicle loading. An enhanced woven geotextile was placed over the subgrade, adding an additional strength layer to the system and allowing water movement without getting clogged by the sandy material. The GEOWEB system was used for access and maintenance roads, as well as pads around the towers. So as before, the GeoWeb was expanded and held open with temporary stakes, then infilled by pushing via dozer. The GeoWeb panels were filled with a low-quality aggregate that could be easily sourced and transported to the remote locations for this project. Once the panels are filled in, both wheeled and tracked equipment can drive over these systems easily, even when the infill material is sand or other low-quality stone. Again, we see how the GeoWeb panels act as their own access road. You just keep filling up the cells in front of you. No need for additional temporary roadways for the construction. This is a great time and resource saver. One important advantage for any unpaved surface utilizing GeoWeb stabilization is the use of open graded base course. Since we do not need fines to achieve compaction for base stability, the system will function like an on-site detention basin, storing water in the void space of the GeoWeb infill. As a generalization or rule of thumb, a 3/4 inch or 19 millimeter open graded crushed aggregate has a void space of approximately 35%. So you can calculate how much water you can store to potentially reduce stormwater runoff and ultimately have the ability to reduce stormwater pond volume and land requirements. There are many ways to place the infill. A rock slinger is one of them. This allows precise placement for fast, even filling while controlling the height from which the aggregate falls. Buckets with extendable booms can also be helpful, though a push with a dozer or backhoe will work just fine. The GeoWeb 3D system is beneficial under hard pavements, including asphalt, reinforced concrete, and roller compacted concrete, especially in areas with soft subgrades and/or drainage issues. Now on to some technique tips for those types of installs under pavements and with large-scale projects. This project for BNSF is a good example of base stabilization, with technique tips of beneficial reuse of on-site materials, staging tables, and site layout, all key takeaways with this big quantity. This is an auto storage yard for BNSF by the Seattle International Airport. It's a 25-acre site that had soft subgrade, and the original design included 2 layers of biaxial geogrids. After bidding, the cost came in higher than the budget allowed, and the engineer contacted us. We did a value engineered solution. In the far left of the screen, you see one of the stockpiles of this salvaged material. This beneficial reuse of material saved a significant amount of material costs and sped up the construction time. Here's a best practice pro tip: staging tables, as staging is important for any large project. So here with the use of staging tables, where adjacent panels are connected prior to being expanded and placed across the prepared subgrade, you see the workers can connect the panels standing comfortably rather than bending over them, and it makes for very fast side-to-side connections. Each panel has an approximate area of 270 square feet, or about 25 square meters, and this contractor is using the tables to connect 3 panels together, providing a total area of over 800 square feet, or about 75 square meters. The staging tables allow the workers to stand while connecting the panels for that quick, ergonomic pre-assembly. Then the panels are transferred for installation. Typical installation rates are about 3,000 square feet, or about 280 square meters per hour with a crew of 3. And remember, work can run in parallel, with one crew laying out the site, another installing GEOWEB, another filling and compacting. This work in parallel, again, for best efficiency. Another technique tip important for large projects is to prep the site layout. In this case, the contractor wanted square panels for the entire installation, so they surveyed and staked the corners of each GEOWEB panel over the 25-acre site. Once the GEOWEB panels were filled, they just pulled the stakes. Similar to using stretcher frames to open panels to a set distance, and we'll get to stretcher frames a little bit later, this hold open and the initial survey and staking made such a large installation go very quickly and very efficiently. Here we see a picture of the installation ongoing with a 4-inch wear surface to allow construction access during the installation. And again, using the GEOWEB system as its own access road for construction. At the far left, we see there where the contractor stockpiled the on-site sandy soils to mix with the crushed aggregate, again, saving construction costs. And mid-screen, the expanded and connected GEOWEB sections. And then the filling and compacting as we move from mid-screen to the right. Again, this work in parallel across the site allows for an even more efficient installation process. Towards the top of the photo, we also see the stakes for the site layout from the site survey. All of these technique tips combined made for a very efficient install for such a large project. You can see the dump trucks back right up to the GEOWEB, dumping the infill material and spreading it with a bulldozer. The material supports loading immediately after filling, no cure time needed, no special weather conditions needed. And again, the material serving as its own site access road for construction. And here's the finished surface. So here's a quick recap for you of some of the technique tips and best practices mentioned for GEOWEB load support installation. See prestogeo.com for installation guides, videos, case studies, and additional resources, or reach out to anyone on our team, info@prestogeo.com, and we'll be happy to share more resources with you. Next, we have some installation techniques for the GEOWEB slope protection system for slopes and shorelines. Whether your slope is one adjacent to railways, embankments along a roadway, a mine slope reclamation, geomembrane protection, shoreline revetment, or other slope application, there are ways to make the slope protection system's installation safer, easier, and faster. So let's go to it. First, we have a quick overview of the installation process, and this is for a slope system with anchor stakes. First, prepare the subgrade, install a geotextile if it's part of your design from crest to toe, then anchor the GEOWEB at the crest. Again, pay attention to that horizontal turn at the top. Expand the sections down the slope, connecting side to side as possible on the crest and the remainder on slope. Continue installing your anchors at the frequency recommended by design, and again at the toe of the slope. The ATRA anchors hold the GEOWEB to slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has an HDPE ATRA speed stake that is designed to work with the GEOWEB system and offer higher resistance to extraction than rebar or J-hooks. Once the system is properly anchored, infill from top of slope down. So here's an example of a railway slope project in Montana with the use of ATRA anchor stakes. Aggregate infill was chosen for both sides of the embankment for erosion control plus a low maintenance slope cover. This project shows the benefit of material delivery at the top of the slope, greatly reducing the handling and truck traffic into the surrounding areas. When such delivery at the top of the slope is possible, it makes for a faster, safer, and easier installation. Here we see the workers installing the stake anchors to keep the GEOWEB section in place. And here the panels are being filled with crushed aggregate. Infill is done from the top down to prevent the panel overstretching. Rock slingers, as shown in the load support section, also work really well for this top-down infill process. And here's a close-up picture showing the GEOWEB panels were extended under the bridge abutments. And a picture of the finished slope. Here's another example from a mine slope with ATRA anchor stakes using waste rock as the GEOWEB infill. And we'll look at a few more installation technique tips and best practices. This project is great to see work in parallel and an ATRA GAD to drive the anchors, with one worker measuring and marking for stakes, another placing them for anchorage, and another using a pneumatic hammer with ATRA GAD to drive them. This site also used an on-slope delivery tote for safe, expedient restocking of anchor stakes. That's a great pro tip. And here with the infill placed and slopes stabilized with GEOWEB geocells. Additional in-field adjustments can be made following a stake pull-out test using a fish scale to ensure actual values match the geotech report and the information used in the evaluations calculations. This quick double check can give you some extra peace of mind for your staked slope protection and is easy and inexpensive to do. Check out Tech Memo number 32 for more information or contact our team at info@prestogeo.com. Some slope protection systems are over a geomembrane or other liner that cannot be punctured, are on very steep slopes, or over rocky soil. In each of those cases, a system with tendons and load transfer devices is recommended instead of stakes or pins. So here's a quick overview of the installation process for ATRA tendon clip installations. Prepare the subgrade and install the geotextile as recommended. At the crest, insert tendons through the cell wall eye slots. Secure the tendons to the crest anchorage. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together, so we go from the problem to design to construction solution with a system where the modeling replicates the real-world forces. Install the ATRA tendon clip load transfer devices as per design and at the crest of the slope, then expand your sections down slope. Connect sections side to side and end to end as possible on the crest and the remainder on slope. Anchor the toe with either an ATRA tendon clip or stakes according to your design. Once the system is properly anchored, infill from top of slope down. Let's see that process with a couple of project installations for examples and to pull out some best practices. This is a vegetated slope project at a solar farm and allows us to show some great step-by-step install pics while pointing out those best practices with ATRA tendon clips. The solar site included a sloped area leading to a large detention pond for stormwater management, and GEOWEB helped stabilize that slope and control erosion. Tendons were laid out, measured, and marked per design, then inserted through the eye slots on the slope crest, with sections being built on the flatter ground where it's safer and easier to work. A suspended rod through the tendon spools is a good technique tip that can be helpful when marking and inserting the tendons. For this GEOWEB slope protection system, a PVC pipe was used as a dead man anchor at the crest of the slope, and here's the connection of the tendons to that pipe. Earth anchors at the crest are another option, especially if the site is not conducive to digging an anchor trench, as with this road embankment. From a constructability standpoint, it makes the downturn of the GEOWEB at the crest difficult, so extra care must be taken to prevent undermining of the system from above. In the rendered drawing, note that slight downturn at the top. That's important. The earth anchors may be installed right through the geotextile, as you see in the photo on the right. There are many ways possible to tie up the tendon to your crest anchorage, whether that anchors a dead man, an earth anchor, or some other means. The specific knot type is up to the contractor to determine, as long as the knot is secure and permanent. One recommended knot is known as the trucker's hitch knot and is a self-binding knot common for tying loads to secure them to a fixed point. It can be tied anywhere in the standing part of a line and can create high tension lines that can be used to safely secure heavy loads. Here's what that knot looks like. And this is Tech Memo 75. Again, reach out to us, info@prestogeo.com, for any more information on that. Okay, back to slope stabilization and pre-assembly. The pre-assembled sections, once connected to whichever version you have of the crest anchorage, are then hung over the slope like a curtain and extended down slope. Again, a best practice or great technique tip is to do all that pre-assembly on the flat or crest of the slope. It's much safer, quicker, and easier. With the GEOWEB system and tendons and ATRA tendon clips, you can pre-measure and mark and know the layout for pre-assembly based on that project design. Let's look at a project to underscore the value of that pre-assembly and show you some pro tips for doing it. This is a real differentiator. This tendon GEOWEB slope project highlights the pro tips of that marking and pre-assembly, using staging tables for pre-assembly of the GEOWEB ATRA tendon clips and tendons, and really shows you the benefits of that ergonomic and efficient methodology. There's an assembly line with staging tables that allows for the pre-building of the slope protection sections. Here you see those pre-built sections marked for location. Well, pre-built, marked for location, and then taken to site to install, ready to hang in place on the slope. Again, these marking guides allowed all of that pre-assembly, which was done on these ergonomic and comfortable tables, then the sections marked and then taken to install. That pre-assembly means much more work is done on the flats instead of slope side. As you see, these slopes were pretty steep, which means safer and more efficient for your workers. So here's a quick recap of some of those technique tips and best practices for GEOWEB slope protection. Installation guides, videos, case studies, and additional resources, visit us at prestogeo.com or reach out info@prestogeo.com. Our next set of installation techniques will be for the GEOWEB earth retention system. Here are the two different wall options in cross section. A gravity wall with longer pieces of web at the bottom that get shorter as you go up, and the weight of the infill GEOWEB provides your retention, or a GeoGrid reinforced section, wherein the GeoGrid provides your retention and GEOWEB functions as a fascia alternative. In either case, again, the front cells can be filled with topsoil or whatever you'd like, and the back cells or reinforced zone, any kind of drainable material. The ATRA wall key is the major component for a completely integrated earth retention system and is used to connect adjacent GEOWEB retaining wall sections through the material eye slots. The ATRA wall key includes an integrated washer at the base of the handle for coverage of the eye slots, frictional barbs for an improved interlock with the GEOWEB sections, and an ergonomic handle with S-shaped contouring for ease of installation. Formulated to withstand weathering and ultraviolet radiation, the ATRA wall keys will not corrode or photodegrade even when exposed to harsh environments. Securing sections with the wall keys is faster and stronger than using staples or zip ties, requires no additional tools, and can be completed by one installer with one easy turn. So here's a quick overview of the installation process for the GEOWEB Earth Retention System. As with other applications, prepare your subgrade and install any geotextiles as recommended by design. The step of expanding the GEOWEB sections is best done with stretcher frames or stretcher bars. Pro tips in their own regard, so we'll come back to those in just a moment. And the interconnection of sections has another pro tip option with the ATRA wall key, which we just saw. Again, color matched to fascia. For vegetated walls, topsoil in the front cell, and any granular drainable material in the back. For a geosynthetic reinforced wall, add the geogrid as recommended by design and shown in step 10. For a vegetated wall, either reinforced or gravity on to step 11. And while reinforced walls are not limited in height, it's a good technique tip to use multiple tiers of shorter height walls. Here we see some examples of those tiered walls rather than a single wall tier. This is because the length of the reinforcement may become too great with just a single tier. Remember, the ratio of wall height to reinforcement length is 70%. So a 6 meter or 20-foot high wall needs about a 4¼ meter or 14 feet of grid reinforcement. A 12-meter wall needs 8½ meters of reinforcement, and etc. You get the idea. Using shorter tiers allows you to keep the reinforcement length reasonable while still achieving the overall required height. GEOWEB walls can be vegetated or non-vegetated, with concrete or crushed aggregate as infill. This wall is benched and stepped back, and we see the ability to change the batter angle over a short distance. All of these adjustments are great options if you need that kind of flexibility in your earth retention system. And we'll offer a pro tip for batter angle coming up in just a few. GEOWEB earth retention systems offer some great benefits beyond stability. Aesthetics and cost are compelling reasons. Here are some others. GEOWEB also helps reduce urban heat island effects and can help green up your urban areas. GEOWEB walls are environmentally friendly due to their no maintenance vegetation and their ability to capture stormwater runoff. Using local grasses and flowering vegetation will help ensure easy growth and a natural look. And the ATRA wall keys are color matched to the fascia, so blend right in. Installation of the GEOWEB wall system is fast and materials are lightweight and easy to assemble. GEOWEB MSE walls are both less expensive for materials and for labor compared with traditional MSE walls such as masonry walls or gabion block walls. And compared to many other wall systems, GEOWEB walls have a lower carbon footprint for manufacturing and transportation. They can help with green infrastructure and low impact development plans for a project site as well. One of the most significant benefits of GEOWEB walls is their relative lightweight compared to concrete MSE walls and the ability to tolerate reasonable differential settlement. So building over soft soils or areas where differential settlement is a concern is no problem for GEOWEB walls, as they can handle several inches of differential settlement. This is vital for areas with saturated soils. Here we see a GeoWeb wall being constructed in close proximity to extremely wet rice fields in Japan. Using the GEOWEB system can help avoid expensive and time-consuming activities, such as surcharge loading a site, which often has to happen when differential settlement is a concern. The time required for the surcharge loading may be reduced or even eliminated when using GeoWeb walls. It also reduces the amount of visual inspection, maintenance, and repair over the lifetime of the wall structure, since the GeoWeb panels can accommodate much more movement than a masonry wall. GeoWeb walls perform well in strong seismic areas and with live traffic loading as a surcharge. It's always necessary to consider live and dead loads that the wall will experience during construction and over its useful life. Dead loads can be buildings or the soil slopes above the wall. Live loads are for construction traffic and long-term vehicle traffic if the wall is below a road or driveway. When possible, the load should be placed away from the edge of the wall or the fascia. If not, the design will need to be robust enough to support and withstand the live and dead loads. Having traffic barriers at the top of your wall will help keep the loads away from the front face of the wall system, which can also help with your design. GeoWeb walls work well with integrating traffic barriers and infrastructure, such as the sonotubes and large pipe culvert seen here. There's no loss of structural integrity because of the continuous web connections with the ATRA wall key. GeoWeb sections can be easily trimmed to fit culverts, sonotubes, or other obstructions. So let's get into some more tips for fitting and for field work. Building a stretcher frame is a definite best practice for GeoWeb retaining walls. And we have plans for wooden ones, ideal for walls with a constant cell size, such as most reinforced walls, or expandable ones that are better suited for gravity walls that have more cells at the bottom and less as the lifts are increased. Check out the Installation tab at prestogeo.com to download the full construction resource package or just the stretcher frame plans. Need any help with that? Reach out to us at info@prestogeo.com. While stretcher frames are great for a straight wall, a pro tip is to use stretcher bars for any curved areas. Our installation guides have plans and diagrams for both. And now we'll look at some step-by-step wall builds so you can see them put to use, and we'll point out those technique tips along the way. Most of the examples will show wooden stretcher frames, but remember they can be out of PVC or other materials and can even be adjustable like this example. Use what works best for your site's needs. Now let's walk through the steps of a GeoWeb earth retention system being built as part of a vegetated stacked channel. Preparing the footing for the GeoWeb wall. On the right, we see the footing layer of the GeoWeb installed with granular infill placed, and you see the stretcher frames and infill process. A pro tip is to have a portable compactor on level with the build and compact as you go. And here are the stretcher frames from another angle. The stretcher frames are placed spikes up, and then the GeoWeb is placed over the stretcher bar. Once the section is open to optimal size on the frame and GeoWeb are flipped over, making sure the fascia panel faces the proper way. towards the front. Once the section with the frame is in place, infill can be put in and then the stretcher frame lifted away. Here we see the frames lifted away and reloaded on the far left, getting ready for the next layer. Don't forget to compact each layer as you go. And the process repeats, going down the line, connecting panels side to side along the way. And again, working in parallel for a most efficient installation. And as one side of the stack channel was completed, on to the other, also using stretcher frames. And here we see the newly constructed GEOWEB walls on either side of the watercourse. And as vegetation begins, the front fascia cells were seeded with a native plant mixture and an aggregate topsoil mix. Notice the slight curve on the wall towards the top of the screen. When your wall has to curve beyond a gentle turn, stretcher bars are a best practice, and they'll hold the wall cells open to the optimal expansion while making the constant curve radius needed. Note the portable compactors to compact this foundation layer. In this slide, we see where the wall path transitions from straight to curve, with the stretcher frame used for the straight portion and in conjunction with the stretcher bars. The process for stretcher bars is similar to a stretcher frame, only in a curve and no flip needed. See our installation resources, including videos particular to placing stretcher bars and other pro technique tips on our YouTube channel. Many of our earth retention project evaluations will incorporate grid reinforcement and call out specific strength characteristics and spacing. Most geogrids will be uniaxial, primarily for cost purposes. Make sure they're installed in the correct direction and appropriate minimum strength. For uniaxial grids, that means perpendicular to the wall face, since the grid only provides strength in that one direction. Again, when in doubt, talk with our engineering team and make sure you have it right before the install. The geogrids will need to be pre-tensioned once laid out. Install the grid as far forward as possible without sticking out of the wall face. Do not overlap the grid layers due to low friction angle and slip planes. Again, follow the geogrid manufacturer's guidelines with that. Most evaluations will also include a non-woven geotextile separation layer placed against the retained soil. Make sure to have the correct overlaps side to side and end to end. And again, follow the geotextile manufacturer's guidelines. And again, reach out to our engineering team with any questions or concerns, and we're happy to walk you through the install process. Drainage is very important and is a topic that needs to be addressed with any MSE wall, including the GEOWEB wall system. Hydrostatic pressure buildup and improper drainage behind a wall face is the leading cause of wall failures, no matter the type of wall. The GEOWEB system is better equipped than impervious walls, such as many of the concrete block walls, because by its nature, GEOWEB allows for water movement throughout the system. However, even with this, it's crucial that you understand your specific site conditions and ensure that hydrostatic buildup is mitigated. One of the best ways to mitigate that hydrostatic pressure is with a drainage pipe installed behind the GEOWEB panels. This could be a perforated pipe wrapped in a geotextile to prevent clogging. This type of drain system is a best practice pro tip you'll want to be sure to include. The drain pipe should daylight in an area that can manage the collected water. The pipe can either come through the front of the wall, like shown here, or can end at the side of the wall, depending on what works best at your site. It's also important to make sure that wherever the pipe drains is set up such that excessive erosion will not occur at the outfall, which could lead to undermining of the wall at that point. Here's an example of one of the more common types of drainage mitigation. The drainage system needs to be designed by the project engineer and can include as many pipes as necessary to ensure that water is properly collected within the wall structure. Our in-house engineering team is happy to collaborate and work with that project engineer to ensure the design holds all necessary components. Using a clean aggregate and other good drainable soil as the infill and backfill can also help with your drainage concerns. If you know there's a place for the water to flow, such as a groundwater system or a nearby lower elevation creek, allowing the water to drain straight through the GEOWEB wall is a good option. The material used in the construction of the wall will have to be sized for the task, so using an aggregate mix with very low fines content would be a good choice. Sandy soil mixes are also good for drainage. Avoid using clay or silty soils, which will impede drainage and cause pressure buildup behind your GEOWEB walls. A drainage trench above the wall can help route surface water away from your walls so the structure does not become oversaturated. Here's another issue to consider along the lines of drainage. If your location is an active channel with flow, that water can be rerouted. Here's a stacked wall channel as an example. Bypassing the construction area, and here's that channel with the water flowing again and the vegetation starting to establish. And then a few years after install, invisibly yet reliably protecting. If you prefer not to bypass or reroute the water, it is okay to construct the GEOWEB system in water too. That's no problem. Stepped walls are a bit of an advanced level install, needing some technique and some extra planning. Our full installation guide gives examples of calculating offset dimensions for a GEOWEB wall on a stepped base. And these type of designs will need some extra care and attention. So make sure to work closely with our in-house engineering team so that everybody understands the site parameters. Stepped walls can be useful, make for an interesting construction such as this. Here the engineer used 3 different wall batters and multiple stepped areas to make GEOWEB fit the site. We mentioned the drainable fill a few slides back. You may also consider grouting the front cells or filling them with concrete when high flow is expected, like in this highway retention pond. Or use a mix of medium, as you see in this project, with aggregate fascia along the pathway and topsoil for vegetation elsewhere. The careful alignment of cells vertically from one lift to another is a good pro tip and worth the extra care. Not only will the wall be more aesthetically pleasing, especially important if it's not vegetated, but the alignment will help prevent potential material loss in the fascia cell that may occur if your cells are misaligned. Here's an example of good cell alignment, and another. Another technique, best practice, and pro tip is to check the wall batter as you build. Here we see construction in process with batter check stations along the way. No problem with compaction or around curves. Same setback angle is maintained. Notice the cell alignment vertically from one lift to the next in the curved area in the photo on the right, and how the batter check boards help keep that consistency all through. Batter checks are a good pro tip to help you build beautiful walls. These project photos are from our Japanese distributors, and they have built many beautiful walls. Proper wall batter with slight setback is not only nice looking, it can help ensure good vegetation for your wall. And we typically recommend a setback of about 5 centimeters or 2 inches, especially if you're considering vegetation. Here we can see the wall structure is constructed with a slight setback to allow that topsoil fill in the front cells. And this can be seeded either by mixing the seeds in the soil before installation or by hydroseeding once the installation is complete. And this turns into this. To design your own GEOWEB earth retention system, request a copy of the MSC wall design software from our webpage, prestogeo.com, in the Design tab. Otherwise, activate our in-house engineering team for a free project evaluation and let us do the heavy lifting for you. Here's a quick recap of some of the technique tips and best practices mentioned for the GEOWEB earth retention system installation. Visit our website for installation guides, videos, case studies, and additional earth retention resources. The following set of installation techniques will be for the GEOWEB channel protection system, as the install process for channel projects can be similar to many slope systems, and as we touched on a bit of the stack channels with GEOWEB walls, and as I rambled on and got us a little deep into the presentation, we're running close on time. We'll focus only on aspects not yet covered, such as hard armor protection and applicable technique tips. Here we go. The GEOWEB channel system installation steps are similar to slope, though as you expand the sections down slope, you must note the water flow direction. The GEOWEB needs to be towed in at the upstream termination. This is an important technique tip. And one you should also do at transition areas if your channel goes from hard armor to competent rock, for example. Key in or toe in at that transition. Again, talk with our design team for additional details specific to your site needs. Continue installing anchors at the frequency recommended. And once the system is properly anchored, infill from top down. If it's a concrete channel armoring, it may work best to fill the bottom of the channel first and then the side slopes from top down. Again, connect with us for recommendations. We trust the GEOWEB system and have the experience and research to back us. We did a big series of channel armoring tests at Colorado State University under the direction of Dr. Chris Thornton. CSU is considered one of the top hydraulic research facilities in the world, and their lab has a couple hundred feet of static head to achieve extremely high velocities and shear stresses in both their indoor and outdoor test flumes, with impressive results for vegetated, aggregate, and concrete channels. Let's get into some technique tips for each. Here's a technique tip for using the GEOWEB system along channel side slopes. Notice the panels just cover the sides, not the channel bottom. GEOWEB panels will allow for vegetation growth up both embankments, which will not normally be underwater. Notice the bright yellow liner below the panels. In this case, using the tendon anchorage system will hold the GEOWEB panels in place without damaging that liner. Even with the liner beneath, vegetation will still grow thanks to the soil held in the cells of the GEOWEB panels. So at this stormwater overflow channel, once it becomes flooded during storm events, the side slopes are protected and the channel will keep doing its job. Here's a project near Phoenix in Arizona that can highlight some new technique tips for us and show an aggregate channel example. Heavy runoff from intense storms were leading to erosion and flooding in adjacent subdivisions. Several existing embankments and channel sections failed under 100-year storm events. Here's a pro tip particular to channels. One of the really nice things about using GEOWEB is it allows for adjustments. Here you see the GEOWEB cell depth reduced from 8 inches to 4 inches. The second half of the channel from the main inlet was subjected to reduced flow rates and reduced shear stresses, and because of this, less protection was needed, so a shallower GEOWEB panel was used, which saved cost and installation time while still meeting the performance requirements. And a seamless transition was made by connecting the GEOWEB 30V8 to the 30V4, as you see here. This is only possible due to the strength of the ATRA key. Staples or zip ties wouldn't provide enough strength and the panels would separate over time. GEOWEB panels are flexible and can be easily cut in the field to allow for pipe penetrations, as we saw with the sonotubes in the GEOWEB wall portion. Again, no loss of integrity to the system's performance. Here we see drainage pipes from a nearby detention pond, very simple to complete field cuts and accommodate structures like these. The infill was waste rock from a nearby quarry, and it was not of the greatest quality, but that's all right. The advantage to GEOWEB aggregate channels is that construction equipment can drive on the GEOWEB areas immediately after infilling, using that GEOWEB channel as an access road to construction. Here's the installation under typical flow conditions. You see the technique tip of adding drop structures, and several were designed throughout the channel to reduce velocity before reaching the end of the channel, so water will be transported to the groundwater system. With the aggregate protection system, there's little to no maintenance required. Since the aggregate is confined, it won't need to be replaced, and the channel is large enough to accommodate large storms without overtopping. Outfall areas can be challenging because they typically have high velocity and shear stress, more so than the channel as a whole. And the water in these areas is usually turbulent rather than laminar and smooth, which can cause its own set of problems. Using the GEOWEB system can help mitigate these concerns, especially when concrete is used, since turbulent flow and high velocities are no issue. For concrete channels, another pro tip is to use the GEOWEB as your formwork and have it contour as needed for your outfall structures. The GEOWEB channel system is flexible enough to modify the structure. Here's a technique tip of grouting in large riprap in a rockfall area of a mine closure channel. Or you can add energy dissipators directly as part of your channel design. If you want a vegetated channel but have strong flows, a pro tip is to include surface protection over your panels, such as a TRM or coir fabric like seen here. This is intended for short duration events rather than continuous flow. If you have high flow or shear stresses for your channel armoring, you may likely be using concrete infill for your GEOWEB channel, like this mine closure channel in Guatemala. Here we see the technique tip of filling the channel bottom first, and then the side slopes. This is to ensure the system stays in place as no stakes are used, but also facilitates construction as crews can traverse the channel bottom as they finish the side slopes. Again, for the side slopes filled from crest to toe. This channel had a drop structure, rapids incorporated. Here you see the joining of that rapids to the rest of the GEOWEB channel with a drone view of the rapid structure here. A pro tip for concrete channel infill is to use a concrete boom pump, as seen here, or a line pump if you have an install easily accessed horizontally. Another important consideration and technique tip is to include site access along the channel crest that can support the loading of cement trucks and other heavy equipment. Temporary access mats can help if design constraints will not permit access as part of the design and can even be placed in water. Here's a quick recap of some of the technique tips and best practices for GEOWEB channel armoring. For installation guides, videos, case studies, and additional resources, see us at prestogeo.com. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs so you can deliver certainty and build with quality materials you can trust. No disclaimers or concerning fine print, and the best quality and service in the industry. Part of our complete solution is our technical assistance. The engineering team here at Presto Geosystems works closely with landscape designers and engineers, offering free project evaluation services for any roads, embankment, or erosion control project. The form is on our website, prestogeo.com. Fill it out with your site info, including attaching documents like geotech reports, site pics, or other info, and it comes directly to us. We've made it fast and easy for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Live webinars are managed separately from the on-demand dashboard. You'll receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. And then in 2 to 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand dashboard and other helpful resources. If you do not receive either of those emails, please check your quarantine folder or reach out to us. Here are my contact details. And I want to thank you for attending and remind that you can send any questions to us anytime at info@prestogeo.com. Go to prestogeo.com for a wealth of information. Don't forget to view our YouTube videos. If you have a technique tip that we didn't mention, please let us know. I would love to hear from you. We went a little long, and I thank you for your time today. For those that can stick around, we have many questions. I'll get to as many as I can before we time out. Again, reach back to us. There's my email on the screen, or info@prestogeo.com. We'd love to hear from you. All right, let's get into some questions. And again, thank you all for your time. We'll go in the order submitted. Let's see. How deep is the GEOWEB at the sawmill? Going way back to the load support, that was 6 inches or 15 centimeters. Just a single layer will do it. How difficult is it to maintain a failed subgrade with the GEOWEB system? It depends on how it has failed. Remove and replace, question mark. Yeah, pretty easy to stabilize that soil, depending on what type of soil it is, if you need to remove it or not. Many times you will not have to fully amend it. Fill out our project evaluation form and we'll take a look, no charge. It's part of our free project eval service. And we're happy to make a recommendation for you. Next question, auto storage. What was the height of the geocell? That was also our 6-inch or 15 centimeter. Many of our load support projects have that 6-inch cell as the main workhorse. It allows a great cross section, typically half of what a non-confined or only grid confined cross section would be, and allows enough water storage needs. Next question, why was the fabric placed first? I'm not sure which example you were looking at, but typically it's the order of operation. Any geotextile recommended will go beneath the geocells in our cross-section recommendations. And there it allows best functionality, not only as a separation layer, and if it's for example, a high strength or a high performance woven, it will also prevent clogging. But offers some structural benefit as well. How much material must be placed at the top of the GEOWEB? It will typically, I'm assuming this means for a load support system, there will typically be a wear surface needed. It varies by design and type of loading and type of surface, but you will see something covering it in any load support case. If we're talking a channel armoring, for example, those concrete channels, that is flush with the top of the geocell. So I guess it depends on your application. Next question, are the stakes driven through the underlayment? So not sure if this is the load support or the slope, but yes. What is the typical design life for the geocell system? We can vary design life to suit whatever your project needs are. Some road requirements, for example, have a useful design life of 20 years. Others need much longer. We've done some with a 100-year useful life. The GEOWEB system is well tested to withstand elements for 149 years without any degradation, even at full exposure to the elements. And it's buried, so it doesn't get full exposure to the elements and will last even longer without any degradation. So we can certainly meet any project requirements. Let us know what you're looking for and we'll work with you. Next question, how high can you go on the wall retention system? It depends. For a grid reinforced wall, there's not really a limit as long as you can have the adequate tiebacks. Remember, they're 70% of the overall height. So if you're terracing the wall and have room for your grid tiebacks, there's really no limit. We have some really cool case studies of extreme walls. Check out our Geo gallery at prestogeo.com to see some of those. Do we do overturning analysis and global stability for earth retention? We have many, depending on your wall needs. Will an independent geotech design be needed? Question mark. Again, it depends on your particular situation. We will need soil details, seismic coefficients, things of that nature. The more info you can input, the more complete an evaluation we can offer. We have some software for you to download and do the design yourself if you wish, or you can have our experts do it for you. Reach out to us with your project information. We're happy to take a look. Does the GEOWEB come in different colors, such as green or blue, to mesh into nature? Usually just black, because of the carbon black stabilization. The difference would be our earth retention systems, which do have color fascia, sand, or green colored for blending in more naturally with most environs. That being said, we could make it neon pink if you like for the right price. If you have something specific in mind, reach out to our team. There are so many more questions, and I'm getting notified from our team that I'm way over time. Sorry for blathering on like that, but thank you for your engagement and for staying with us. If I didn't get to your question and or you have a technique tip we didn't mention, I would love to hear from you. My contact details are still on the screen. or reach out to us at info@prestogeo.com. Thank you, everybody. Take care. Bye-bye.